Hello, everybody. Welcome to a special edition of the Heathen DriveBYE. Today I have Purple Dan, who has a channel on YouTube, and he talks about geology, debunks science, and
I
scientific
don't,
pseudoscience, I
so,
should say.
there we go. Yeah, I don't debunk
I,
science.
I misspoke, sorry. And how are you doing, Dan?
I'm doing all right, chilled. We just had a little bit of a tiny holiday.
Oh, really? What kind of holiday is that?
I'm not sure. I didn't follow what holiday it is. It's just a holiday.
There's local holiday.
Yeah. It's probably something about freedom. I don't know. Didn't care.
In America, we have a holiday every day, so it's just great here.
No, no. I don't really enjoy the holidays too much. I get lazy. That looking forward. Like, tomorrow is back to uni again, so that makes me happy. Then I'm not lazy.
Uh, before we came on live here, we were talking with Dan, and I was talking to Dan, and we were talking about radiation and stuff like that. And um, what was it that we were? Oh yeah, you have mining in your area, and you were talking about
Yeah.
when they
Not in
harvest.
my, I wouldn't say my area. I would say my country.
Okay,
More in the central area.
gotcha.
There's a big resource of uranium, so it's just describing the dangers of uranium processing. Because when you're dealing with uranium, you're not dealing with really high energy level gamma particles, anything during its decay. It's just really not that much of an issue. You're mostly looking at alpha decay, which is just the release of hydrogen. Uh, no, not hydrogen. Sorry, a helium
Okay.
particle from the nucleus. So it goes through a decay chain until it reaches lead, which is stable. The reason I know a lot about uranium decay rates is it's essential for uranium lead dating of rocks. Not the dating, taking out to a stake house dating, it's the dating of how old they are. That's a very funny joke, I know.
We'll
But
laugh at it
yeah, but that's more of a tangent. What I'm really trying to say is alpha decay is not that dangerous when it's happening outside your body because your skin can deal with it. If there's any sort of damage in your DNA in your skin can just
later.
your skin will the cell would just kill itself and there'll be no real problem. Uh, but the decay doesn't actually uh, saying it probably not the correct word to use, but it doesn't really dig into your. It doesn't penetrate. That's the word. It doesn't penetrate into your skin as far as let's say gamma decay would. So the problem is when you breathe in radium dust, or it gets into soft tissue like your lungs. You swallow, ingest it, then it starts decaying inside your body, and obviously there's no thick skin. Like yeah, so there's no real barrier to prevent from just interfering with your organs. So then you well die from radiation sickness. It's usually a very long and painful process.
Yeah, yeah. Well, yeah.
Yeah, so
Something I
you
don't
can
want to do.
so you can imagine when you have processing of these materials, you somewhere have a dump of the mining waste, and if there's a lot of uranium still left in that waste, and the wind, because I mean South Africa is pretty arid, most places pretty arid, and most places are really windy as well. So you can imagine how easily the dust get swept up and flow into housing areas where there's people, and breathing in this stuff is not good. So yeah, that's pretty bad.
Yeah,
And obviously a lot of people from we were talking about how companies would big oil companies and stuff would try to whitewash their process of the things they do.
yeah. Of
But
course, they got to make it look
yeah,
like.
over here we had the similar thing with mining companies where they were like, ah, no, it's we really did treat it properly, but they obviously didn't because it's much cheaper to just fucking dump something and actually treat it. Because treating these sort of waste materials is extremely fucking expensive.
Yeah, yeah.
And because once you like let's go through an entire process. Let's say you're digging for gold. Now you see gold hunters and stuff on TV, like on Discovery Channel. They're digging for gold nuggets, and most of the processing they do are it's damaging to environment in on an attractive basis. Does it make sense? Like you're fucking up the environment, but you're not actually. You're
Eh,
just basically digging shit up and sieving it. It's not really fucking up anything chemical wise.
Oh,
You know.
basically, the oil companies have think tanks thinking not about how to save the environment, but how to make their company look good. They're basically a PR freaking thing for
Yeah,
how they can
obviously.
rake in more money. That's just my personal opinion. Maybe they don't. Maybe they're really nice guys that are out to help us all out.
No,
But
no.
I doubt it. But
But yeah, this is what I was.
like this channel that I was talking to you about before. They call their name is Clear Energy Alliance. What's so fishy about that name? Sounds like could be clean energy. No, it's not. It's clear energy. So they're just kind of disguising what they are. That's just a semantic game there. But go ahead.
Yeah. So what I should probably just cut this short, quite short. The idea is that whenever you have a company that is doing processing, either being it with oil, with be it mining, once you've extracted the material you need out of a material, like let's say we extract gold from this rock, the gold can't just be sieved out. It has to be crushed. It has to be treated with chemicals. It has to be reacted with chemicals that could actually extract gold.
Yeah.
So to get, and
Huh.
these things are usually pretty fucking bad for the environment, obviously. But so you've extracted all the chemicals out of you've extracted all the gold out of a slurry, and now the slurry is useless to you. No more processing will get you anything out of it. You know, like some mining operations, you can still process the material and get something out while making it safe for the environment to dump it.
Yeah.
In this case, usually uh, whenever you're treating it, you're spending a lot of fucking money. So companies would love to be able to just dump it somewhere and leave it, which would, save them a fuck ton of money.
Yeah, of course.
So obviously, companies would. I mean, companies only care about the money, obviously. So they don't actually care about treating the waste, and so they wouldn't do it out of the goodness of their heart. They wouldn't just go, fuck, let's treat it. It's bad, good for the environment. No, there has to be some pressure, either being it from private companies or from the government, to force them to treat the waste. So in most countries, excluding some third world shitholes, not that South Africa is not a third world shithole, uh, you, the
Different.
government. Yeah, the governments force the companies to treat their waste, and if they don't treat their waste, they're liable to extreme fines.
Yeah.
So these are sort of things that you can draw parallels with what you're saying of big energy companies. If if they are, let's say let's take nuclear power, because I personally love nuclear power,
Uh huh.
but obviously the main problem with nuclear power is nuclear waste.
Well, the waste.
Now,
Yeah. That's if it wasn't for that, we'd be using it right now.
yeah, so there are some good ways to deal with it, and then there are some really silly ways to deal with it. Good ways being packaging in really thick concrete containers and digging it deep underneath the earth. It's expensive though. It's extremely fucking expensive, but it's good. So obviously, energy companies would love if it were just able to just package up neat little thing and just ship it off to some
A
country.
nice
That
little
would be
vacuum
nice.
cleaner to come out there with it.
Yeah, and just like throw it on a pile somewhere in the middle of Africa. That would be nice. Because it wouldn't cost them a lot of money. But
Throw it and put it in the owner of the backyard or the owner of the mining company's backyard.
yeah, so then if you start arguing about that, then I can start playing devil's advocate. As in, I mean,
Uh-huh.
it's not hurting anyone. I mean, let's go.
Here's the
Let's
problem.
build
Yeah,
more
here's the
nuclear
problem
plants. I
with
mean,
stuff like pollution and stuff like that. When a big company becomes like that and they have lot of a lot of pollutants that they put into the environment, fluid water is fluid. We have rivers. Once you put that in that river, it's going to go to somebody
yeah,
else downstream. You're not just infecting your little
dude,
area that you're living in.
dude,
You're everybody.
That's not even the problem. You don't even have to have it close to a river. It's
Well, yeah,
literally drawn into the ground, into the water
exactly. But
table.
I'm just speaking in general with pollutants, any kind of
Yeah,
pollutant. They're going to
yeah,
affect everybody around you, not just that little area that you're in. So
yeah. But so you have campaigners now that can argue against nuclear energy, say nuclear energy is bad for the earth, whatever. I mean, where are you gonna? I see these stickers on people's eye, like these MacBooks and stuff that say no nukes and whatever, and I'm like, to power that fucking laptop, all the machinery to create that fucking thing. Do you know how much energy that requires? Do you know where that energy comes from? It comes primarily from fucking coal, and coal is disgusting.
yeah, it's the
There's
worst.
nothing, there's nothing clean about coal. I mean, natural gas, like most of the natural gas that you get, that's still pretty damn clean, but it
Well, there's
still
actually
releases
radiation coming out
CO2.
of coal too, correct? There's actually a radiation
Uh,
coal, isn't there, from burning it?
um, not really. Most of the gas I'm talking about is gas contained in oil shales.
Okay. Yeah, I'm
Yeah,
not too familiar with it.
yeah.
I'm
The
late.
problem is that it still contains carbon dioxide. No, it's combusting something, a carbon-based thing will always give you carbon dioxide. That's a reaction. There's nothing you can burn that contains carbon that won't give you carbon dioxide as a byproduct. So you have to deal with the carbon dioxide. It's a greenhouse gas, and you get other greenhouse gases as well, um, like cows pooping and spewing methane and stuff. And if you can catch that stuff, that would be great, but that's a logistical nightmare.
Yeah.
Imagine having little tanks on the back of every cow. I'll be crazy. Um, but the
Use
problem
chicken.
with yeah. So most of my point when people argue about energy and where they come from, they usually do the whole, yeah, but what about green energy? What about solar panels? What about wind? There's two problems. Number one, is fucking expensive. Number two, it's fucking inefficient. It really is so inefficient. It's people don't understand how easy it is to get energy out of coal. You put it in a fucking chamber, you throw a match in, it burns, you basically make steam, you run a turbine. Hey presto, there's your energy.
Yeah.
Simple, cheap, and it's effective. Wasteful, but it's effective.
Well,
But that's my cat.
I don't know about what it's like for you in your country, but in America, the electricity comes from the light switch, so we're you're pretty immune to what all goes into actually getting that energy to you.
Yeah, yeah. So when you start there are obviously really interesting ways that they're trying to do green energy. Like there's a project in the States, or well, quite a few places around the world. I'm not even sure if the projects are actually still ongoing. But with you've seen those mirrors that just capture light and point it to a single spot, and then like
Yeah.
boils water and runs a turbine. I find those things fascinating and brilliant. And there are many ways to capture energy from the sun and wind. And up until the point where the technology behind those things improve. Like my university, there's one of my friends. He's doing his PhD now. He's working on photovoltaic cells, and the they really are putting a lot of effort behind these methods of energy. And according to him, it would still be a few decades out before getting solar panels that would be really cheap enough to completely replace uh, like carbon buildup. So
Yeah.
because you can't expect a developing country. Let's say you take South Africa for instance. I mean, it's our government's fault that we don't have money, right? Because they fucking spend it on fancy cars and fancy planes and stuff.
Yep.
But
Yep.
even then, for South Africa to go and shut down all its carbon or its coal burning plants and replacing it completely with solar energy, even if we take the entire GDP of the country, we wouldn't be able to do that, just because it's just so expensive. So you can imagine with ongoing research, we'll eventually get to a point where it gets better.
Yeah,
So,
well, that's the thing. Get the cost down. Yeah,
so
that's
let's
the whole
get.
thing about it.
So I think we can go full circle back to what you say about this person trying to say that global warming is a myth.
Well,
Um,
it doesn't help that the oil companies campaign against it so hard and try and put
yeah,
pseudoscience into the mix or cherry pick data
yeah,
and stuff. That's my
yeah,
whole issue with them doing anything. Let the
yeah.
science, weigh it out a little bit more instead of having your shills go out there
I've
trying to, you know.
That's the thing is, I don't know if you actually have personal experience with this because I've never had, even when I was studying geology, I never actually had people talking about energy in that way. Because I studied geography as well, and
Yeah,
usually that there was
what
more
is your history on?
interaction.
What did you all study when you were at school? What are your credentials?
Uh, really, I just did my third year in geology.
Okay,
So basically, I have a degree
cool.
in geology. I didn't finish because you have to have two majors, obviously.
Hmm.
Well, at my school, you have to have two majors. So I had half a major of geography as well. So then I went out of university for 2 years, simply because of financial reasons. And this is when I made my first YouTube video as soon as I got out.
Okay.
But
Yeah, I love your channel, man.
oh, thanks, thank you very much. But then after the 2 years, got enough like work jobs and stuff, and
Uh-huh.
that sort of thing. Finally got enough money to go back to uni, and now I'm basically doing complete hard science, just chemistry and physics.
You're smarter than I am.
Because nah, I just realized I really have a soft spot for physics, and
Yeah, well, that's whatever you love. That's kind of what you get good at, I think.
yeah,
Usually.
I don't know why it's we had this lecture now. This is the problem that I think is that I don't usually tell people is that I was brought up Christian and I'm not a Christian anymore. So, but you'll never find me really talking about religion in my videos.
Yeah, yeah. I haven't seen you do that yet, but
Yeah,
and
and I don't
yeah,
think I ever will. So it's just something. I guess if you look at the type of religious people you generally find in South Africa, or they're the typical religious people that that's on the Sunday they go to church and
what are all the
when you
denominations that? What are the major denominations there then with that?
Protestant.
Protestant. Okay.
Yeah. You the major one is Protestant, but there's this little subgenres of Protestant. But in general, you very, very rarely find someone that's obnoxious about the religion.
Yeah, yeah,
It's usually when people ask me how, I wouldn't even say I'm an atheist because a lot of people are scared of the word. So
yeah. No,
in general, I'll just say I'm not religious, and they're like, oh, okay. They just don't care. I have the story that might tell you later about how I lost a job because the one I was interviewed by no, I was assessed by a young earth creationist, but that's a different story. In general, that's not a problem. So back to my story.
all right.
The physics department at my university, the people are very religious, very
Uh-huh.
so much so that they sometimes bring it up in class, but in a very subtle manner that kinda I find kind of cute because it's you get an insight into some of the people's lives. Like this one, my lecture now, he wrote this. I had a last lecture from him like 2 weeks ago, and he's now retired for good. Very old guy. Well, very old, I say. I think it's about like 67 or something. He should have retired a few years ago. But anyways, also religious guy, Afrikaans guy, brilliant, and he
Yeah.
made me love physics. But in this one, we were doing a derivation on kinetic energy and potential energy. and then how everything you can derive everything from a very basic concept to all these things. And he said this is beautiful, and I agreed, it was pretty beautiful. And then I think in the last week of his lecture, he did a derivation for Newton's gravitational law. It just relates to the force of gravitation between two objects of a distance. And then he did a derivation for Coulomb's law, which is the electrostatic force between two objects of different charges at a distance. And they boil down to being exactly the same thing with just a constant changing. If you write them next to each other, they look like a mirror image from each other. And he says that symmetry for him is too beautiful to have just happened by chance. And he just kept quiet, and he says, but yeah, we're not allowed to talk about those things in class. And he went on. And I found that was so, it's almost so, like I said, cute. Because in his mind, this is how he obviously believes in God, and this is how he has made himself believe that what he knows about God is true, because of the all the symmetry in the universe. Now, someone like us who rational will know it's just a coincidence.
It's just too good. See, now my family is
Yeah.
they were my great grandmother, my great grandmother, my grandmother, my mom. They're all non-believers, so it was pretty
Okay.
easy for me to. So I grew up being one, and but I found out just like you're saying, it's just easy to. They don't really talk about it unless you start engaging them, telling if you tell them that you're not that you're an atheist, then they'll engage you. But
Yeah.
yeah, I didn't have to. I didn't really have to say anything. But when I do see in my country though, it's you got fundamentalists like that are trying to
Oh
push it
yeah.
down your
Of
throat. So
course, you get them everywhere.
yeah,
But I usually, whenever it comes to Christianity,
and
especially like
especially when it
um,
gets to being put into your government policy, that's where I'm like, hey, come on now, I'm done.
even when it comes to that sort of thing, I don't really particularly care. I just have this really fucking disgust for people pushing not necessarily religion into education,
Uh huh.
but just plain wrong fucking science.
Exactly. Yeah.
Be it based out
You're wrong.
of yeah, I mean, and you see this obviously with intelligent design. You see it with Ounces in Genesis, really, because have you seen that video from me and Pelagia?
Yep.
Yeah, where about Ounces in Genesis trying to
Paul's the
well,
one that made me find you.
Mhm.
Paul's the one that made me find you that long, I don't know, about 6 months ago or
Oh,
whatever. You're on. You're on.
oh, yeah. Now I remember.
Yeah. And then we went through the YouTube apocalypse. Then you came on my channel for a little bit. And I was going for like 8 hours straight. And it's like, oh, sorry, Dan. We're just shutting down now.
Yeah, that was funny. Oh, with anti-ordinary.
Yes. Yes.
Yeah, there we go. Oh no, it's what can I say? Wait, where were we? We were talking about something that was apparently interesting. Oh yeah, I
Well,
was talking
in the chat,
about
they're talking about aliens. Go ahead. Sorry.
nah, what else? What else is there? There was something I wanted to. Oh yeah, the one time I basically lost a job due to being
Yeah, there we go.
not fun of grade. So I work this job I worked at. They had like a mental assessment of the certain time because I was doing contract work, and obviously I can't name any names or whatever. But so at this job, after a certain amount of contract months I've completed, I was eligible to be hired permanently. So first, the problem with the job is was a very security orientated job. Reason being, I was working with cash physically.
Okay.
And I'm not talking about cash, I'm talking about a fuck ton of money. I'm talking about even if I change it from rands to dollars, I'm talking about millions of dollars. There's a lot of money I worked with
Uh-huh.
physically. So obviously you can imagine that security is a big part. So this I have to go through this little interview thing with this guy where he assesses my stability and my I don't even I don't even know what all the stuff he was supposed to test. It ended up just being a really interesting conversation because he asked me about where I studied, and I explained to him I studied geology, that sort of thing. And he asked me how old is the Earth, and I said I gave the usual quip like 4.5 billion years, and he asked me why. So at this point, when he asked me why, I was like, this is not usually the question people ask me, but I know why, and I explained to him how uranium dating works, and then I figured either this guy's just really curious or there's something else. It's because he just feels a bit uncomfortable with me talking about the age of the Earth. And that's when he fucking dropped it. And that's when he said, I don't actually think the Earth is old. I think if you look at the Bible with Noah's flood, I think the Earth can only be around 10,000 to 6,000 years old. And then I fucking lost it. Well, internally, of course, I didn't show it. This is where I know this is literally the second person. I've met many old Earth creationists, many of them. I've actually went to university. I know a lady who's doing her PhD now, and she's a young Earth, old Earth creationist who doesn't even believe in evolution, mind you. Yeah, I know it's weird, but here's the second person in my life that I met in person that's a young Earth creationist, and
Wow.
so now I'm trying to describe because obviously now I have to play the really thing. I can't be a dick because then I'll lose the job. I just have to not to give in because I'm not gonna lie to myself and say no. Well, yeah, sure, yeah, I'm wrong. So I did the whole proper scientific thing of saying I can be proven wrong if you give me the evidence. If you can prove that a decay rate can change over a certain time, then sure, I'm gonna give it to you. If a young Earth creationist can prove that the decay rate of uranium changed the last 100 or so years, if they can prove that, then I would say, well, fuck that
There's
then.
one thing I do know about it is the decay rate is pretty constant.
It is extreme. It is
Yeah,
constant. Yeah,
yeah, I was gonna
yeah,
say it. And there's
yeah.
no evidence
So
showing to the contrary to that. So,
yeah. So as soon as you get evidence, it simply means that we can no longer use radioactive dating.
yeah.
Which could mean that the Earth is obviously much younger than 4 billion years. The problem is, it still wouldn't mean the Earth is 6,000 years old. It would probably move the Earth. Well, first off, if let's say let's make a scenario up. Let's say tonight is a paper releasing and it's proven to be correct that indeed the carriers can change. The
Uh,
second point, the second point we're going to want to see by how much does the decay rate change in a given time. Because if the change is if the change follows a pattern, follows a function, be it linear, logarithmic, quadratic, whatever, if it follows a pattern, we can build up the mathematics and still prove the Earth's age from radioactive decay chain, from a radioactive decay chain. If it can be proven that it's random, as in one day it's twice as fast, and the next day it's half as fast, then obviously we can no longer use it reliably. So, fuck, that word came out wrong. Reliable. I can't say that now. Can you say that reliably? Can you say that word for me? I'm not English. Hello?
Can you hear me?
Yeah, I can hear you. I think I just spoke a half an hour
My
to
computer
you.
froze up. So I'll be a little quieter. Sorry. I had to go on the laptop.
And here I am just talking like an idiot. No,
No,
it's
that's
cool.
fine.
It's cool.
As
It's
long as you're
cool. It's
talking,
cool.
it's great.
Can
Okay,
you
where were
send
we?
me?
My computer froze up on my
Can you,
on
will you
my
just send me? Can you send me a link to the actual video? I just I wanna see the chat.
Now, yeah, hold on. I'm moving out of the room around it. Otherwise, hold on.
Alright, it's funny.
On the other mic there?
Hmm?
Did you hear me on my other mic? I can put
I'm
the
hearing you.
iPad right here now.
Yeah, I'm hearing you loud and clear.
Okay. And tell me if you can hear me in a couple seconds. Can you hear me now?
100%.
Ah, good. Hold on. Okay, where were we?
I was. Were you? Did you hear what I was describing? What would happen if? I was just basically describing what would happen if the K rates change over time.
Oh yeah. You were I heard that actually, and it's recorded. So
Yeah. So
if you were
the
talking,
whole.
it was good. Nobody even knew I was gone. I bet.
Well, I didn't know you were gone. I was just
Well, there
like,
you have it.
nah. So, uh, yeah, we're now
So
in
the
this.
K rate.
Yeah, we are imagining now that K rates are now proven to be inconsistent completely. They change from day to day. This means that we have to abandon all modes of radioactive dating. So now we're sitting with a age of 4.5 million years, and now or 4.5 billion years, and we have to go back to what was previously thought. So previously, I can't exactly remember how they determined. I think it was to do with the heat of Earth, and it was the idea was that they formed a model at how far Earth would have how long it would take for Earth to cool from a certain state to another, and apparently it was like just over a couple of million years. So I'm not exactly sure what other method you would use, but you're gonna use something that's relative, as in you're probably gonna uh
I gave you
you're
a link. I gave you a link to the chat, the
yeah, cool.
live.
I see.
So cool.
Yeah, yeah. So the idea would be you have to use a relative thing like tree ring dating, ice
Uh-huh.
layer dating, those sort of things.
Yeah. What
And
is it? What is the oldest ice core that we have?
Hmm?
What was the furthest back we can
I
look?
fuck, I don't know. I honestly do not know. I
Oh,
know it. I know of
you've read
one
it before, I
that
bet.
yeah, I know of one study that had ice cores like over 15,000 years.
Okay.
Yeah, so it would be much older than the flood.
Yeah, find the right spot. Yeah, there might be a spot in the ice that's way
Yeah.
deeper than that.
But yeah, of course. I mean, I wouldn't be surprised if you can go back a 100,000 years or something.
It'd be interesting if you could. Yeah, they get a pretty good idea on what's going on. Alan Geisdorf says he sounds like from South Africa. He's from Britain, so
Oh
he's a
well.
friend of mine.
Oh yeah. of course.
I couldn't tell. I couldn't tell you from a Londoner. Let's put it that way. So
Really? Oh yeah. Yeah. I don't know. I'm really good with differentiating accents. Um, it's probably the first time I meet new people at university and they have a funny accent. I have to point it out immediately. I do not know why. Yeah.
I'd say, well, now that I've talking to so many different people with accents like that from that area, and I can tell the difference between Australia and stuff,
Oh yeah.
and but not between Australia and New Zealand though. I couldn't tell the difference between them two.
Neither would I. I'm not able to. I was never put in the spot to do it, so I don't think I'd be able to because to me fucking who's the guy uh
Ken Ham.
yeah, I can't differentiate the accent between Ken between Andrew Snelling and what's the banana guy's name again? Ray Comfort. Yeah. I know I think it's Ray Comfort. I think he is actually from New Zealand, or is it Ken Ham?
He's
Well,
from New Zealand. Yep, he's from New Zealand. Yep.
yeah, but they sound the same to me. Yeah, so I don't know. Um, that's so funny. Like I find that my English sort of starting to die again, mostly because I'm not doing any videos. And at university, I have my friends are right now mostly Afrikaans, so I speak Afrikaans most of the time. So
Okay.
when I'm doing videos, I get more. I'm in a better mindset to speak English. So things come out more smoothly instead of the way I'm speaking now, which is sometimes a bit funny. Sometimes I don't really get the words sometimes right. It's actually a shitty excuse because I should be fluent and perfectly in both. But yeah, that's just my excuse, and I'm sticking to it. Fuck it. That and
You know,
but
I do have a question for you about what is the process that somebody said that the elements do not change. They never
the
change.
what don't
Um,
the
Elements
what?
don't change on the periodic table, like stuff like that. But
Yeah, they don't change.
he said is that we can't make gold. We don't know how it's done, but there
That's
is a way to do it.
bullshit.
But
Of
it's
course you can.
expensive, isn't it? Energy
Yeah, yeah,
costs.
yeah.
Go
Yeah,
ahead.
it
Explain.
would be
I
ridiculous
want to know about
expensive.
it.
So when uh, most of these sort of things, if you're dealing with creating new elements, there's a couple of videos on periodic videos that deal with creating super heavy elements, like uh, the elements past. Well, anything really above from uranium. Actually, everything above uranium. I don't want to make that general. Let me just quickly check because I don't want to make that statement if it's completely false.
Yeah.
Yes, everything above uranium is not found in nature. Um, they
Anything
are
above it?
yeah, everything above in as an atomic number, everything above
Gotcha.
92 is all artificially made, as in either being created in nuclear explosions
Like two
or
suns
some.
colliding.
Well, I would rather go and say just a normal Hiroshima bomb. But
Okay.
I've no doubt that it's entirely possible for some natural process to create these elements, but obviously they're extremely radioactive, so they decay extremely quickly into something that's more stable. That's why they're simply not found in the crust, or if they ever are found in the crust, it'd be well, they wouldn't be found because they would been long gone by now, decayed into something that's
Okay.
yeah. So let's say a kilogram of fuck. Let's just take something silly like Lawrencium was made when when two stars collide. By the time those elements or the dust actually form something that's long past the decay rate of Lawrencium. Like what is the decay rate of Lawrencium? Maybe quickly check. Uh, no, the most stable half life is 10 hours. So if you have a kilogram, you can just quickly draw a graph and you can imagine how fast that just disappears.
Yeah.
Yeah,
That's quick.
but yeah, well, getting back to what you actually
Alan
said,
says element 115 better than rocket fuel. Smiley face.
Moscovium.
Element 115.
Yeah, it's Moscovium. Um, Now, if you take an element like, let's say, organism or organism, that's how it's
Huh?
pronounced actually. First you create, I think it's berkelium. So you have to undergo a process to create berkelium, like a berkelium target, and then finally, when you have a berkelium target, I think they hit it with calcium. No, that would not make sense. Actually, you would have to have californium to hit it with calcium. Yeah, something like that. Basically, you have a target and you have a massive fucking accelerator that projects these ions at an immense speed, and you have to get the speed just right. Too fast, and it just obliterates the nucleus. Too slow, and they just bump off. So you have to get the area or the speed just perfect. And even then, the chances of them actually ever combining is extremely fucking slim. So you spend most of the time just bombarding a sample with these elements. Eventually, eventually, they break off and they decay, but they decay really fucking quickly, like in microseconds. Well, I think it's microseconds, milliseconds. I'm not a nuclear physicist yet, but
Uh,
uh, they will decay, and the decay is has a signature. So when when you have organism and it decays undergoes a certain amount of alpha decays and beta decays, then it forms a pattern, and it those elements that it's released from its decay chain that you actually measure at the end of the day, and that's how you can determine if you've actually made a bit of organism or not. So you're talking about creating in a session of maybe an entire day of running, you may be creating like 10 atoms or something. So yeah, that's that's not a whole lot. If you just think about it, that's 10 atoms from a whole day's work. If you think about, let's say, if you want to make uh 196 grams, 196 grams, 197 grams of gold would take uh would be like 6.62 times 10 to the power 24. Is it 24 or is it 36? Where's my calculator? I don't have my calculator close to me. This is weird. I always have my calculator close to me. But yeah, it's
and your hammer?
no. Hold on. Give me 2 seconds. 2 seconds. The it is 20. It's 23. It's 23. There you go. Okay, I'm correct. 6.022 times 10 to the power 23 atoms. It's Avogadro's number. That's how much. That's how much atoms there are in a mole of 197 grams of gold. But that's just school chemistry right there.
Okay. Yeah.
Yeah. Yeah, so you can imagine, and you only have 196 grams. You can see how making elements are not a very easy process. And there's little gaps in there between in the elements as well. You'll find that even numbered elements are more abundant than odd numbered elements.
Yeah. Yeah.
It's weird. I'm trying to find a picture so I could actually show you. It's the bun elements. This forms a really cool pattern. There we go. This is a really uh typical thing. Where can I send the link?
Hold on a second here. Go ahead and just put it in the side chat where I sent you the link to the.
Uh yeah, there we go. So there's just a really simple thing that can show you the balance of elements. Obviously, the higher up in the graph they are, the more abundant they are. This is for the Earth's crust, by the way. This is abundance in Earth's crust. Well, not just the crust, but the entire Earth in general. So,
There. I put it out
are
in
you
the
on
chat.
are you on the graph?
I was actually tweeting it out so that, or not tweeting it, but I put it out on the chat out there so they could get to it. Everybody out there could get to it too. Let me see if I can get you to present it here. Now you should be able to put it up right on the channel here. I think. Try it once.
Oh.
But there's a little thing on the left hand side that says screen share,
Oh yeah, yeah. I've
and
done
then you do that, and
this.
then it'll show you the thing. Then everybody here in this audience can see it too.
I've done this before. Let me just quickly check. I don't have
I know I'm
anything.
getting used to it. I'm getting better at it.
Yeah, I'm just checking. I don't have anything on yet. I shouldn't have on yet. Okay, there we go. Everything is good. No funky tentacle stuff.
I think it's working.
Okay. Yeah.
Can you see it out in the chat, guys? Can you see his presenting in the screen GI? Yes, it works. Go ahead, Dan.
Good. So you'll notice that that even numbered elements are more abundant than odd numbered elements.
Okay.
Yeah. What you have here is, for instance, oxygen. Oxygen and silicon are the most abundant elements in the Earth's crust. It makes sense because most of
Yeah.
the most of the elements and most of the rocks are silicate-based rocks in Earth. So, and aluminium is pretty fucking high up there as well. So
Aluminium.
yeah, so
Sorry.
so when you see things like aluminium up there, and you think back just a couple of years ago, aluminium was extremely fucking expensive. Well, a couple of years ago, a couple of hundred years ago, simply because extracting it out of rocks was just so damn expensive. So it was, well, people thought it was, more valuable than gold because it's fucking takes a lot of money to extract it. Turns out that's not the case. It is really fucking abundant, along with things like iron, manganese, and titanium. Titanium also being pretty difficult to extract. But then you notice something really fucking interesting. And then when you look at some seriously rare elements down this little, the graph even neatly says, and just so we're not sure, this is rarest metals, and
Uh-huh.
they're indeed really damn rare. And you notice the popular ones:
So
gold,
basically, what is it
boron.
when you get to the element heavier? Like two stars colliding. I did read something about that where I created that where they claim they've witnessed gold being created by two stars colliding. That was just recently.
Oh, well, I
What
would
is that
actually like to
process
see
then? It's
both.
actually the density getting pushed together
Oh,
to convert it into that element, or what?
um, no, it just means that there was a really small time frame where the temperatures and the pressure was just
Okay.
perfect for fusion to get to that. There are some other
Fusion.
processes. Hmm?
Yeah, fusion is the word I was looking for.
Yeah, there are some other processes as well that are not. There's a proton exchange. There's another process as well, but it's not an exothermic; it's an endothermic process. It requires energy instead of releases energy. Yeah, so fusion obviously is very exothermic, but some of these are not created by fusion; they're created by different methods. Not everything is just due to things smashing together, because fusion only, well, as Kent Hovind said and correctly said, that fusion only really creates elements up to iron and sometimes nickel. But you see there's a very sharp decline after iron. It's
Okay.
because it's really
Yeah.
fucking difficult to create those metals.
Yeah. Okay.
Uh, yeah. This is not super accurate to trying to deduce that from this graph,
Uh-huh.
just because this graph only refers to elements. You'll see helium is actually absent from here. Uh, this only this only this only the way they actually get this thing here is they take samples from rock chondrite meteorites. This means meteorites that are really good samples of how the Earth crust was at the big, well, basically the formation of the solar system. So you take the sample of that thing, break it down into whatever elements are in there, and then you relate everything to let's say silicon because it's really abundant and yeah, it's easy to work with.
Say, I'm
The
wondering. I see your mouse pointer there. Can you move that and make it point at what you're looking at too?
Oh, can you actually see the
Yeah, you
mouse
can
pointer?
now. Oh, cool. So
Oh,
you can use. Oh, cool. Another new tool for you.
okay, cool. Yeah, so let's just put it at gold. Yeah. So what I was basically saying, uh, you wouldn't use this to really judge how abundant things are in the universe, obviously, because there are certain elements that are well, not everything is distributed evenly throughout our solar system. So you're going to have to look into different methods to check what is ever is abundant. Remember, everyone listening here, don't take my what I say as pure fucking gold because it's not.
I
I'm
say
not a
that too.
doctor. I don't have a PhD. Just whenever you hear me say something that you don't agree with, go check up, read on it. And just yeah, like
As should we for all
don't yeah. Please don't believe everything I fucking say.
plants.
Because I might make I have made some really fucking dumb mistakes in my videos in the past, and I'll tell you later about one that was really interesting. But yeah,
All right.
here's something I find really interesting. Look how low lead is when compared to things like iron. And obviously this is a logarithmic scale, right? So this means something like oxygen is extremely fucking more abundant, many times more abundant than gold. But notice how things like
Alan
osmium.
Alan said helium is absent in this chart on Earth question mark, but its presence in is it present in meteorites? Did I hear that?
No,
It is present.
no,
It
it's not.
is present.
It's
Is
not.
what he said.
It is.
No, he said, but it's present in meteorites. So did he? That's if it is
It's
present in meteorites.
um, it's helium is present as a de- decay particle. Yeah, yeah. If you look at helium in rocks on Earth itself, they usually be contained in a crystal lattice as part of a um, decay chain uh, due to alpha decay. But on things like meteorites, I'm not exactly sure.
What if we were out in a space shuttle and picked a meteorite before? Well, actually, a meteorite's technically not a meteorite until it actually goes through the atmosphere, is it? So it
Yeah,
actually,
yeah. Let's just
but
call it let's just call it a
when it's
space
an
rock.
asteroid or a rock out in space, does it have helium in it?
Yeah.
That's the question.
I
And
don't
I
want to
looked up.
say I don't want to say no, it doesn't, because I don't actually have proof
That's a
that it
good one to
doesn't.
look up, actually.
That's something I have to look up. Yeah, because
Yeah,
what I do remember is while working from this graph, because we use this to relay certain crustal, because you use this as a crust fingerprint basically. So you you read this uh, as a as crust that's undepleted of any minerals. Because if you have subduction, you have the crust going into the earth. Some elements are leached out. Like a lot of gold is leached out, and you'll find it in what you call it. You'll find it in
quartz.
no. Gold is chalcophile, I think, or it's a lithophile. Basically, what it means is things like iron and nickel will draw the gold out. So you'll find a high concentration of the gold in the center of the Earth instead of at the crust region. So
Okay.
yeah,
Okay.
I think I have a better version of this graph somewhere on my computer. That
Godless
is
Iowan
that.
says, yes, helium is present in meteorites, and
Mhm.
they can use the meteorite content to judge the age of the meteor.
Thank you for that. That was something that was bothering me now for a few seconds because I whoopsie.
We got good people in the chat here.
Yeah, that's good. Let me just quickly look for that thing because it's not accurate. This thing because I'm listing the things. I think this is actually you'll see now if I can actually find the one I want to share. I still have all the shit that I have from uni still on my computer somewhere. It's here somewhere. There was this. Now I'm confused because I can remember studying something at uni about a really big deficiency of helium in rocks on Earth. Also,
Um,
I think I see somebody just linked a paper, which is
just to say,
really
I just
cool.
sent the link. So you're
Sorry,
presenting it.
I'm presenting.
Yeah, yeah. You can. I think you're still sharing your screen. Oh, you're no, you're not. You don't have your graph up there anymore.
Yeah,
But you're. I still have you on presenting mode. So
yeah. I'm just gonna look for this particular. It's here somewhere. I'll find it. But
is the
yeah.
Earth hollow?
Yes, it is. It's completely hollow.
I was there. What was that? Me and Stephen Bauman were. I, I showed him this one thing or whatever, but it was talking about the Soviet Union at the one time they shut the hole down. And this guy says, "Well, we tapped into hell or something like that because it was the deepest hole ever dug at that point, and
Okay,
like
I just want
they
to
quit in
quickly
'80."
apologize because I think I have some fucking. I think my brain is farting something because actually 0.2% of the crust contains hydrogen. Not in its obviously not in its elemental form. It contains hydrogen, yeah, but not as gas
Okay.
as H2. You find it in well, as a chemical bond, but only
Yeah.
0.2%. Now. I'm really fucking wondering why the hell I thought that it only
Did your
one
brain
day.
fart?
Yeah, one day I'll remember what information I got wrong. I'll tell you,
And it'll be
and
when you don't really need to worry about it anymore. So you forget it again.
it'll probably
At least
be
that's what I do.
it'll probably be while I'm trying to fall asleep or something. Suddenly I just remember it or something.
And then when you wake up the next day, you'll forget it again.
Because when I said it, I was like, yeah, there's no hydrogen. Wait a minute. How could there be no hydrogen in rocks? This doesn't sound. This doesn't sound really that right.
Uh-huh.
Come on. Ah, here we go. Oh, this is so much better. This is so much better.
Cool.
This is actually normalized.
Share it to the screen.
Yeah, come on. Fucking Windows. I absolutely hate Windows.
I got a Mac.
Fucking Rick Scan. Actually, usually I need to use Linux,
Oh, okay.
but I don't have everything set up um, to actually share. I mean, do a Hangout. Okay, there we go.
Oh, that's
Now,
nice. Yeah.
yeah,
There we go.
yeah. So you'll see things like there you go. So the lecture kindly noted that you have everything above iron is usually fusion, and everything else is neutron capture, among
Ah,
other things.
yeah.
And like I said, even, greater than, odd. But there's some common things that's pointed out here. Uh, Things like how rare lead actually is. It's fucking rare, dude. Look at it.
Uh,
If you compare it to things like like copper, zinc, nickel. And remember, this is a logarithmic scale. So just because there's a tiny difference between two on the graph, it doesn't mean it's
oh,
just,
oh, right.
yeah.
Hold on a
You
second
know,
here. Layman here. What does logarithmic scale mean?
a logarithmic scale simply means that the scale you go from, let's say, 1, which is this is a log base 10. So the difference between 1 and 2 would be, this 2 would be like 100. So it's 100.
Oh,
That's,
so it's kind of
yeah.
scaling
So
them both the y and x positioning are
no,
different
no,
on
no,
this.
no, 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 no. Well, of
Okay.
course, there's a difference, but so you have
Scaling,
1,
I mean.
yeah, 1, 10, 100, 1,000, 10,000, 100,000, 1,000,000,
Okay.
10
Okay.
million, 100 million. Well, yeah, like that.
Okay.
That's how
Gotcha.
that
Gotcha.
scale works. Um, so if you look at if you compare things like platinum and lead, platinum more abundant than gold, but it's more difficult to get because it's not set, just because it's been depleted out of the crust. It's been removed from the crust by tectonic action or geo geological processes. That's the nice big word that encompasses everything. That so I don't need to go into detail about everything because most of the time I don't even know about the detail. Because from here on out, shit just gets really fucking complex. What you see here is the little bit of actual science that's going on in geology. The rest of the shit is not. When you're talking about
Uh,
geophysics and geochemistry, that's real science. If you talk about,
you need
I'm not
hard
gonna,
science versus soft science.
yeah, you get some really silly, especially sedimentary stuff. Sometimes it's
Yeah.
just, it's laughable.
Yeah, I
But
got you. I get that.
yeah. So if you look at the things that you really think of as being how can you say, cheap, tungsten.
Uh-huh.
Look at tungsten. It's supposed to be more fucking rare than gold,
Ah.
but
What
tungsten
about
is not lead.
graphene?
Yeah, but
What about graphene?
graphene is carbon, dude. Like
It's
that's,
carbon, but it's a thin layer, right? Like as thin as you
yeah,
could possibly get.
yeah,
Okay.
yeah. No, but graphene is made.
Yeah, yeah. Okay, never mind.
So it's so anything that's made in small quantities because it's really complex will be fucking expensive. But yeah, so there you have carbon,
Yeah.
and carbon is pretty abundant. But yeah, so something
There's
like
my brain
tungsten.
fart for the
Yeah,
day.
so when you have something like tungsten, uh, which is which is less abundant than gold, but in real life, you don't pay like fucking hundreds of dollars for incandescent bulb because if all of a sudden the tungsten price were to rise higher than gold's price, people will be salvaging incandescent bulbs, breaking it open, removing the tungsten, and selling it. But you don't get that.
Yeah.
It's simply because the gold has been leached out of the crust and it's mostly found in the center of Earth, whereas tungsten is not because it's not the element might not be. uh, if not, might have there's two suitable electrostatic forces that would incorporate better into certain crystal lattices, so it wouldn't be leached out. But then you have some other things as well. Bismuth, for instance. I mean, you,
Yeah.
yeah, you don't. If you see a bismuth crystal, you don't look at it the same as you look at a fucking gold bar. You wouldn't steal a bismuth crystal. You'd steal a gold bar because it's just, yeah. But obviously, if you look at uranium, uranium is fucking rare and it is fucking expensive. So that's the sort of thing that does make sense. But yeah,
It's
it's
hard to harvest it.
well, yeah,
Because of its scarcity. Yeah.
yeah. There's many reasons why it's expensive.
Yeah.
But yeah, again, hydrogen, helium, it's fucking abundant, and I have no idea. I have really no idea why I said it would be not abundant because it's you
It's
would not
part of it.
find. Yeah, the thing with hydrogen is, it's not hydrogen, sorry, helium. The problem with helium is it's a noble gas. It just doesn't fucking bond with fucking anything.
Yeah.
So
Yeah.
you wouldn't find it as part of a rock. Um, that's bonded to something. Like if you think of oxides, do you think of hematite? Do you think of iron oxides? You think of iron bonding of oxygen. You just don't get it. So if you have helium in a rock and it's exposed to the air, it's leached out and it drifts to the top of the atmosphere and it gets blown off by solar wind. Or probably not solar wind, but there's I think actually that's exactly what happens. Yeah, it just gets blown off. That's why eventually we will run out of helium. We will, because there's nowhere else on Earth. You don't get pockets of helium you can go harvest.
Uh-huh.
And yeah, and as soon as it escapes into the air, it just floats to the top and then gets blown off. But yeah, that's basically it. There's not much else I wanted to show there.
Okay. You know, it's just a AIG is I just had to going through some of their articles. It just pisses me off to no end. Sometimes reading some of their crap, the way they come up with shit, and it's like, I mean, if you have fifth grade education in science, you could be able to refute their shit. It's like, come on. I don't know. I mean, that's one of my biggest things. I'm an activist mainly because of the younger creationists and stuff like that. Ken Ham and crap like that, trying to push shit out. So that's that got me into it. Otherwise, I'd just be sitting back, well, not even paying attention to. Oh, I won't be hanging out with all these good people here.
Yeah. Well, uh, now that
So
I
thanks,
do, I do,
Ken.
yeah, I do say, well, there's a couple of things that piss me off really. Obviously, it's whenever people brainwash children.
And
Mostly,
that's
I think it's mostly because it was done to me. I remember watching Ken Hovind's videos with a friend when I was like, I think I was 10 or 9 years old. I absolutely fucking ate up everything. I fucking loved Ken Hovind. I thought he was brilliant. Whenever at school when we spoke about evolution, because we did actually learn about evolution in primary school. Primary school is like when you go to school at like 10 or whatever. Well, sorry, you stop going to primary school at like
oh,
12. There we go. Yeah, that's when you stop primary school. Then you go to high school. Whatever. Anyways, I remember absolutely fucking loving Ken Hovind's shit. And whenever we learn that shit, I would just regurgitate the stuff I learned from Ken Hovind's videos. But yeah, that's one of the things that pissed me off because I've undergone that. So I also bad science. Science communication is at a fucking terrible, terrible state. People like Thunderfoot really put out there how horrible science communication is. If you see people just
it's
freaking
that is really poor.
like, I know Thunderfoot has some really silly things, but the one thing I don't know. I don't even watch his videos when it comes to politics or social. I just don't fucking. But whenever he's talking about wrong science, I eat that shit up because
Yeah, yeah.
I test some of his claims as well. Well, the claims I can test with mathematics, I tested, and actually, he's correct. Um, Especially he's doing this recurring thing. He's beating a dead horse by this point, but he should just go on beating that dead horse. Is this with the Hyperloop and Elon Musk, which is also a South African, by the way.
Okay.
Yeah, Elon Musk, South African. Fucking brilliant dude, but he has some really shitty business, well, really shitty ideas when it comes to technology, and Hyperloop is one of them. And things like that, how people just eat it up, and
Well,
you get people,
the thing is,
you get people like
we try. Oh, go ahead.
go on.
No, what eats me up about religion does create a confirmation bias, and they don't see it. I always look for that in everything I do, or at least I try to. I know I have it. I know we all have it.
Oh yeah,
But they just don't see that confirmation bias. They come up with it. I think logically in that sense, but they don't realize that they're coming to a conclusion without any evidence.
yeah.
And
I
that's
mean,
subtle in a lot. That's what I hate about some of that stuff is
the
that it tries
the,
to
the
blend
problem
hard
is,
science and soft science
yeah,
and
the
create
problem
that
is
little threshold line that nobody notices.
the problem with the whole Elon Musk thing is people attach Elon Musk to SpaceX. SpaceX is
Mm-hmm.
successful. It's fucking amazing. It's brilliant. I love it. Elon Musk is not the one who's actually building the rockets. There are engineers doing that, scientists doing that, and
Yeah, exactly.
that's great. But the problem is he has something that's brilliant. And now people see, oh well, SpaceX is brilliant, so obviously everything the guy touches must be fucking gold. It's not. Hyperloop is one example. It'll never fucking work. And if it, well, it can work, but it would be ridiculous, ridiculously dangerous, and whatever. Anyways, let's just ignore that for now and let's get back to bad science. So I saw this one I fucking love science article about why does stuff not pass through stuff? As in, if if atoms are mostly free space, why don't we just like fall through things? And they describe it by saying they use Pauli's exclusion principle for it. And I really feel
Yeah.
bad for all these really ridiculously brilliant quantum physicists. People like, oh, let's start with the one everyone knows, Albert Einstein. Let's go to some lesser known ones like de Broglie, Schrodinger. Everyone knows fucking Schrodinger. And these people are absolutely fucking brilliant, but they're probably so misunderstood by people on the internet, by so-called armchair physicists. I think I do you know the channel 60 Symbols?
Who's?
60 Symbols.
No, I haven't heard of that one.
Yeah, this
60 symbol.
yeah. Pretty that was a fucking big channel, I think like 679,000 subscribers, whatever.
I'll
So
have to check it out.
one of the scientists on there, this is like it's this one thing that's just ridiculous on the internet is armchair physicists. People who have no formal education in physics, know nothing, but they absolutely pretend like they know fucking everything. And that one friend I spoke about, the one who's doing his PhD now, obviously doing a PhD in physics, obviously he's had his undergraduate and postgraduate education in quantum physics. And yeah, he says I should prepare my asshole for that because it will be fucking horrible. But anyways, so I really
Oh
had a little
man.
tiny introduction on quantum physics, just simple, basic, just interactions of atoms. Now, now these people then go on to describing and saying, no, it's the quantum principle, well, Pauli's exclusion principle, saying that no, two atoms
Okay.
cannot be at the same place in the universe at the same time. This is why they can't. touch. That's why things don't flow through each other. Number one, it's fucking bullshit. This is exactly not what Pauli's exclusion principle actually is. Pauli's,
I
Pauli's
can't see the
exclusion,
chat right now.
yeah, Pauli's exclusion principle simply states that you can't have two electrons having the. Oh, am I presenting? No.
I I haven't been able
Yeah.
to get the. Hold on a second here.
There's three of you now.
Okay, can you hear me?
Yes.
All right, go ahead.
Okay. So
I think you should be presenting here now.
yeah. So what Pauli's exclusion principle simply states is that no two electrons can have the same quantum number. So you have quantum numbers which describe their state around an atom. Like for instance, you have the spin, which yeah doesn't really actually. There we go. Guitar Dog just said it. That's exactly what it means, right? Yeah,
Yeah.
that's exactly what it is. So people take this saying this is the reason why shit don't fly through each other, and this is so fucking wrong. It's like they completely this is like they completely disregard what uh, other quantum interactions there are. You know, like I don't know, electrofucking static interaction. That do you just ignore the fact that there's electrostatic interaction between everything? Let's just ignore that. This is the same thing. You see, a lot of people say that things don't touch other things because apparently everything floats on top of each other because of electrostatics. This is
Ah.
also this is also very 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 bullshit. They do touch. What's the definition of touch? When things interact under close proximity, right?
Yeah.
And
Yeah.
so you can argue. I mean, sure, I've seen people argue that when you have two materials coming to proximity, then they'll at one point the force of them being pushed together is outweighed by the force pushing them apart. At that point, you have equilibrium between two forces, which would one being caused by your hand pushing something together, and the other would be the electrostatic force pushing them apart.
Yeah.
Yeah, that's touching.
Yeah. I agree.
That's touching. That's literally what it means. So then people say, yeah, they're not really touching because if you remove the electrostatic force, then you can push them further together until the little atoms meet. Well, sure, but that doesn't happen.
Yeah. That's
So so you have people, physicists, who argue about this. Like I'm not talking about armchair physicists. I'm talking about people literally in the field that argue about that.
uh-huh.
And I'm on the field that say yes, shit, touching, even if it's electrostatic force, it's still touching. There's still interaction in a very, very good space. So obviously, this is a bit it gets a bit confusing because most of that, the word touching, it's because we have a definition to what touching means in a regular sense in real life. Like when you take a glass, I have a glass in my hand now, and I put my finger on it and I remove it. There's a fingerprint on it because I touched it. So in real life, things scale up pretty well. It makes sense. As soon as you go down to a really microscopic level, beyond microscopic, like on a quantum level,
Yeah.
things behave things behave silly. So a lot of people try to take these interactions and then scale it up to macro size, to a size where we can interact with it. The problem is that that doesn't work. You can't scale these things. Period. If it's quantum entanglement, you can't scale it.
Yeah,
If it's
I I, I can almost comprehend it, but yeah,
yeah.
I kind
Well,
of
I mean, yeah. So I've heard many people argue about some kind of things, like people saying, you can walk through walls. It's just unlikely. That doesn't work like that. Not at all. On
okay.
a quantum scale, yeah. On a macro scale, no. And I know this simply from first year fucking intro level quantum mechanics you get taught in a chemistry course. The There are some really fucking interesting things about quantum mechanics that I've spoken to about my one lecture. And obviously, I'm by no means I'm by no means an expert on this, obviously. But the really interesting thing about quantum mechanics is not the shit you see on TV or on these shows, but the actual interaction you can measure about how how interactions between elements behave in chemistry. If you look at interactions like covalent bonding between different elements, for the simple lighter elements, things make sense. Like a lot of our models accurately describe it. Even if you just use the really simple Bohr model of how an atom works, these sort of things kind of make sense. You can drop mathematics around them, and you can accurately describe what would be the forces between, let's say, a let's take a not a covalent bond, but uh, let's take an ionic bond, for instance, between a really common thing, a chlorine element,
Okay.
or atom, sorry, not element, atom,
Uh-huh.
and a sodium atom. These two combine electrostatically because they have a really high difference in electronegativity between the two. So you can sort of use Coulomb's law to describe why they're interacting with each other, simply because the one is negatively charged and the one is positively charged, right?
How do you spell Coulomb's law?
Coulomb's law is U
CO. Okay.
Coulomb. Coulomb? Fuck me. Don't ask me to spell shit, dude. I'm borderline
Spelling
fucking
bee.
this. No, I'm borderline dyslexic. Fucking just borderline. If
Yeah,
I
sorry,
if
but I was trying to. I want to look that up. I've heard it and I've never looked. I've never
Yeah,
actually.
guitar dog. Say, hey, Coulomb.
Ah, cool.
Hey,
We got
I
it.
wasn't
See.
wrong. I wasn't wrong. Yay. I'm happy. But yeah, yeah. So when you describe two atoms binding like that, it's quite fucking simple. When you start going to things like how uranium makes a salt, gets fucking crazy, dude. It gets ridiculous. And so much so that there's quite a few times in my classes where the lecturer would describe something, stop for a minute, then go, "Oh yeah, but this is not exactly how real life works. You should study it, believe it, but whenever someone asks you, just say you don't really know, because in third year or in honors or in PhD, you'll learn how it actually works because it's too complex for you right now." And you're just sitting there going, "You fucking what?" And this has happened so many times where the lecturer would describe something and just go, just relax. You'll learn the full story in a year or two.
Yeah, well,
You just want to fucking shit yourself.
that's what the Bible claims.
But
We won't find out until we're dead. So.
yeah, but the problem is,
uh,
not the problem, but that's just the nature of these things. It's so immensely complex that if you dive deep into
I get
one
it.
thing,
Yeah. Wow.
things start to overcross. So you have to start by laying a nice foundation by just diving a tiny bit into one, and next one, next one, next one, and then the next time around you can go deeper, and so on and so on and so on.
It's almost
But yeah,
philosophical.
it really is. But yeah, I like talking about these sort of things, but I'm just not. I'm not. Uh, I don't know enough yet, and that bothers me so much.
Yeah, I'm always trying to learn. I love learning new things and figuring things out.
Oh yeah, it's
Not that
so
I'm great
fucking
at
interesting.
it, but I try.
Yeah, like right now I'm busy with physics at university, but I'm just doing basic mechanics, and to me that's fucking fascinating. Anything, anything, anything to do with special relativity just makes me happy, and then I'm in my zone because special relativity makes complete sense. Anything that Newton said is law in my world right now.
I think dinosaur fossils are one of my passions too. I love
Yeah,
looking at that
as
stuff.
soon as you as soon as you go to general relativity, shit just doesn't like start making sense anymore.
And it's like, yeah, great, I love it.
Yeah, fuck.
It's complicated, that's for sure.
Yeah. Well, I see Mrs. Sucks as well that she doesn't know anything. Yeah, I don't know. I'm just spend every day just learning
Oh,
more.
Shannon Q put up her second video already.
Well,
I just got a notification for it. Sorry to interrupt, but
like,
I thought that was pretty cool.
I'm gonna disagree with guitar. I wouldn't say special relativity simple math. The math is not that simple. It really isn't. If you look at some really basic things, if you look at just the law, the take Newton's second law, for instance. Unit acceleration is proportional to force over mass, right?
Equals F dash M, right?
No, that's it. No, like, or most people say it's Newton's second law is force is equals to mass times acceleration. That's not entirely accurate, actually. Newton's law, it's actually has to do with momentum. So
Momentum, okay.
yeah, and it's extremely.
Yeah, because yeah, okay, yeah, I see.
The reason it's based on momentum. If you look at something like a rocket, right? A rocket has, if you send a rocket into space, it has a changing velocity
Uh-huh.
because it has a change in position. Then it
Yeah.
has a change in acceleration because it has well, sorry, no, has a change in position. Therefore, it has change up. Therefore, it has velocity. But the velocity is also changing. Therefore, it has acceleration. But the acceleration is also changing.
Yeah. Wow. Okay. So in other
Yeah,
words, with time
yeah,
and momentum, how much time it takes you to get from one spot to another is kind of what we're
yeah,
really measuring.
yeah.
And
Uh,
what
The,
that goes for down, up, falling, or whatever,
yeah,
right? So okay, gotcha.
the reason why rockets are so interesting is because it's actually pretty simple because you know what's happening. You know that you have you have thrust, which gives you a force.
Yeah.
At the same time, the force is changing because you have you don't just have you, you don't have the same acceleration. The acceleration is changing. The reason the acceleration is changing is because you you have a difference in mass at one point than the other because it's burning up fuel,
Okay.
right?
Yeah.
So
Yeah. The
yeah,
fuel becomes less in there. Yeah. Where you're
yeah,
going. Yeah.
yeah. So that's simple, right?
Yeah. It should be.
So
I
yeah,
think.
unfortunately, it's the maths make sense when you keep things constant. When you start changing things, you have to use calculus, and then things become a bit more difficult. But at the end of the day, it's not spooky, you know. It's just when you dive through all the mathematics, the stuff makes sense and it's happy. But Kiro says force is derivative of momentum. Is it? Let's see. Hmm.
Yeah, Don changes his name. I was talking to the guys in chat. How you doing, Don?
Who's done?
He's another freaking atheist.
Freaking fucking atheists taking over the world. Fucking non-believers.
You're on Twitter too, right, Dan?
Oh yeah.
Okay, I think maybe I do follow you. I don't know. I can't remember.
I do.
Pretty sure I've seen you tweeting, but I don't
Yeah.
recall.
Some do tweet.
I'm AFA.
Hmm.
AFA.
Yeah. Well, I'm a freaking atheist. Yeah, I'm so inactive on Twitter the last while.
Yeah,
I start,
some people don't do that much.
yeah, I used to be quite busy, but then again, I mean, whenever I have time, I'd rather just, do work, study, and that's it. That's why I don't even make. That's why I don't make videos anymore. It's because I just do work.
Do you got any ideas on a project that you're gonna do next, or haven't you really thought
Uh,
about it?
not really. I am soon. It's gonna be like a really big holiday, like a month and a half holiday. So I'll probably be making videos during then. But in the meantime, no, I can't afford to waste time basically.
Yeah, you got to take it takes time. People don't understand that. It's not that they don't understand it. People just have a short attention span. If you
Nah, I mean, I don't mind doing videos for Loja because he has everything sorted. Like
He's
he
pretty
knows what.
organized, isn't he?
Well, I mean, all he has to do is just he says, "Okay, we talk about this video." He sends me the video. I break down all the geology parts.
Just gives you the you break down the technical stuff and do what you do, and that's easy enough to do, right?
Yeah,
Yeah.
yeah, I can just do it on. I can make a script. I send him the script. He approves. Then I just work from the script. I don't have to film.
You got to make fun of George's freaking PhD. You got to do that. Yeah, there.
George?
Georgia, the one on Ham's daughter, or whatever, Ken Ham's daughter, the whatever she always
Oh
trying to
fuck!
do.
Don't
She's the
even know
big
who she is.
pseudoscience one there.
Oh yeah.
Apparently, what I've heard, these are the stories going around, is that she ignored she didn't even pay attention to some of the technical stuff that went against her religion. That's how she got her PhD or whatever. They still let her have it somehow. She just learned what she needed to do to get her
Hmm.
degree. She can blab falsities. That's my goal, is to get the people doing fake science and purposely doing it, especially people doing it on purpose. And I think I would say Ham is one of them. There, I said it.
Fuck me. Okay. Yeah.
Take care, Gia. What do you want me to sing? Another freaking atheist. You going to sing today, Johnny? I don't know. Do I got a guitar here? Yeah, I got one here.
Yeah. So I was a bit confused by what the guitar dog said. He says forced derivative of momentum. Yeah, it's kind of confused, but yeah, it is actually derivative. It's just derivative with respect to time. Yeah, that makes perfect sense now. You have to forgive me. I'm quite slow. Also,
Oh yeah, I can forgive you. But I'm pretty easy. Man, I don't know about the other people out there. Anyway.
and then another question it says, in orderly creation, why is the graph on elements like the one I showed so squiggly? Because God did it like that, um, just to confuse us. To to put a little pothole in the road of atheists.
big sweeping generalizations.
Mhm. And yeah, that's exactly right, Ricardo. That's how Newton explained the second law. And yeah, you can use the derivative of momentum. You can use that to derive the rocket equation.
Alan, very possibly we could do a jam later.
It's just yeah, it's just silly because when Nicodemus said first I did was I wrote down momentum, the equation for momentum, and I used force, and I had to relate it to before I had to agree with him. Ah, fucking, I'm such an idiot sometimes. Well, most of the time I'm a fucking idiot.
Same here.
Anyways, it is getting pretty late, and I should probably be looking and going
Okay.
to bed.
Yeah. Well, it's got to be about midnight there now, huh?
Yeah, it's been an hour away. Well, 45 minutes, something like
Okay.
that.
Oh,
And
when I
that,
want to plug off, I'm gonna sing one song then for everybody, and then I'll shut down
yeah,
the chat here. So.
yeah, I have to get out of bed tomorrow at 5:30.
Well, I want to say everybody, if you have not subscribed to the Purple Dance channel, you should do that. He does some good stuff on there. Like you said, he hasn't been too busy lately, but
Yeah,
I'm sure when he does,
it's
you're
gonna
gonna like
pick
it.
up. It's gonna back up again. And thanks for Guitar Dog for being, you know, open-headed, unlike me, who is very potato.
Yeah,
Most of the time, I'm a complete fucking potato. It's, it's one thing whenever I'm on a live stream and people ask me something really specific about geology. I just sit there going, "Fuck, I know this, but I don't know this."
yeah. It's nice to be able to have that your research. You can look at the stuff up to whatever and find
I
out.
should actually
That's what I
I
like
should
about videos.
I should build myself a nice little um bookshelf just at the top of my computer. So with all the books like labeled, so whenever there's a question, I know exactly where to get it.
Yeah. I agree.
Thanks, Guitar Dog. That's pretty cool. It's pretty cool of you. Okay, so I'm gonna go and get some tea and then go to bed.
Alrighty. Well, thanks a lot, Dan. And
That's fucking correct. Uh, okay, cheers, eh?
cheers,
Bye.
mate.
Bye.
All right, everybody. Well, uh, I'm gonna sing this and then I'm gonna shut her down. So thanks for coming out, and we'll talk to y'all later. I won't let her, or should I say, she won't let me. She showed me a room, isn't it good? No, being good. She asked me to stand, she told me to sit anywhere. I looked around and I noticed there wasn't a chair. We sat on a rug, bidding my time, drinking her wine. We talked until 2, and then she said, it's time for bed. She told me she worked in the morning and started to laugh. I told her I did and called off her sleeping laugh. And when I awoke, I was alone, desperate and alone. candle I lit a fire. Isn't it good? Going. Thank you. Good night.